Hello! So lately, I've been wondering, does the temperature in my room meet the definition of room temperature? If not, what is the temperature of my room? In that case, what the heck even is room temperature? Well, after about 3 seconds of Googling, the consensus seems to be around 75 degrees Fahrenheit or about 23.9 degrees Celsius. Why do I need to know if my room temperature meets this criteria? I don't know, but it makes for a fun and cheap Arduino project. I will show you all today how to build an Arduino circuit that will tell you if the temperature in a room meets the internet's definition of room temperature. Now, if you don't already know, an Arduino contains a microcontroller, which is the brains of this entire design. With the Arduino, you are able to access this microcontroller through the input and output pins on the side. Basically, the Arduino works by taking in specific data points, called inputs, from different sensors. Then, you would write in your logic. The logic is what you want to do with the data. Finally, you have your outputs, or what you want to do as a result of the data you find from the sensor. Here's the plan for the circuit. I'm going to first take in data from a temperature sensor. I'm going to use the DHT11 temperature and humidity sensor, since it is the most convenient and effective method of measuring temperature in an ambient atmosphere such as in my room. Next, I'm going to define my outputs. I want to print out the temperature onto an LCD display. I also want to create a line of LEDs that will show me the color green for if my room is room temperature, red for if my room is too hot for my liking, and blue if the room is too cold. As an extra bonus, I will also make a button change the temperature reading from Fahrenheit to Celsius. Now let's wire everything together, starting with the DHT11 temperature and humidity sensor. We can use a breadboard to prototype our design, using the sidebars as a way to give easy access to the power and ground for each of our components. The DHT11 temperature and humidity sensor has 3 pins. I'm going to connect the data pin to the Arduino pin 2 and the sensor's power and ground to the central power and ground. Then I'm going to connect one of my outputs, the LCD, to the Arduino. The LCD and the I2C bus combo has 4 pins: power, ground, SDA, and SCL. Connect power to power and ground to ground. Then connect the SDA pin to the A4 analog pin on the Arduino, and the SCL pin to the A5 analog pin on the Arduino. That's all for the connection to the LCD. Next, let's deal with the LEDs. Since the LEDs are an output, it would make sense to connect its power to an output pin on the Arduino and the ground pin to the central ground. However, we need resistors for these LEDs so that the amount of current flowing through the light won't cause it to overheat and blow up. 330 ohms should be enough. Finally, I'm just going to wire up this button. The button requires power and ground like the other components, and the data pin will be attached to the Arduino. Provide the Arduino with some power source, and it'll be good to go. Now onto all the code that will power this circuit. Coding with the Arduino IDE is pretty simple to understand. The format begins with defining all the variables that you need. Then, you set up the board and anything else you would like to run one time in the setup function. Finally, you put all the code you would like to repeat in the loop function, and the program will run your code indefinitely until you decide to cut off its power. For this project, we're going to import 3 libraries, and these are the Liquid Crystal library for the LCD, the Wire library for I2C communication, and the DHT library for the temperature sensor. The libraries contain several key functions that will assist with simplifying the code. Next, this section of the code defines all the physical devices that are connected to the Arduino through the input and output pins. The Liquid Crystal I2C line defines the side of the LCD that is used. In this case, we're using a 16x2 segment LCD. According to the documentation of the DHT library, this is how we should define our temperature sensor. This line instantiates the sensor so that we can use it in our code. The next few lines define the input and output pins in which the button and LED lights are located. Finally, these lines of the code represent the variables that we are going to use in the program. In our setup function, we're going to set up the LCD, DHT sensor, and state whether the button and LEDs are inputs or outputs. Now for the core parts of the program, which is the loop. First, there is the delay. Now this delay is pretty important because the DHT sensor does not work fast, so we need to give it time to think. After the delay, the program will run this function to check if the button has been pressed. After that, the program will read these 3 values from the DHT sensor: humidity, temperature in Celsius, and temperature in Fahrenheit, printing out an error message if any of them fail to retrieve a value. Next, the program runs the temp check function, which is responsible for controlling which LED to light up. Let's take a look at the function. First, the function clears all the LEDs and turns them off. Then, there's a conditional statement that decides which LED to turn on. If the temperature in Fahrenheit is greater than 80 degrees, then the red LED will turn on. If the temperature in Fahrenheit is less than 75 degrees, then the blue LED will turn on. Therefore, our room temperature range is defined as between 75 and 80 degrees Fahrenheit. During this range, the green LED will light up. Finally, we will print the results of temperature and humidity to the LCD. If the button is pressed, which is controlled by the variable logic, the program will swap between different units of temperature. And that's all the software that goes into making the circuit. Now let's test the device. I uploaded the code into the Arduino, and I have a 5-volt power supply sitting right here. In conclusion, plugging this into the power supply will tell me that my room is at room temperature. Great! So I just wanted to show you all that the temperature sensor really works. Here I'm going to put the entire device into the oven to see what happens. We wait a bit for the sensor to realize where it is, and as you can see, the red light turns on because the sensor detects a temperature higher than 80 degrees. Now I'm going to put the device inside my refrigerator to see what happens. And as expected, the light turns blue, indicating that the sensor senses a temperature that's lower than 75 degrees. Great! Now we can use the device in the future to see if the temperature in my room is at a comfortable level. That's it for this video. If you like the video, the device, or room temperature in general, please give it a like and a subscribe to help this channel out. Thank you for watching, and I'll see you in the next one.